All right, hello and welcome to Ops 215, our session today titled Better Together, GKE Threat Detection Powered by Security Command Center. Thank you all for attending next and coming to the session. My name is Daniel Lahamadou. I'm a product manager on the GKE team focused on security. And when I'm not working on Google Cloud and GKE security, I like to get outside, hike and bike, and I'm very involved in coaching youth sports.
Hi, I'm Craig Ingram. I'm a security engineer on the GKE security team. And yeah, outside of work, I also spend a lot of time outdoors with my family, doing fishing and things like that.
Great. So we got a good agenda for you today. Just to quickly go over it, we'll start by introducing some of the challenges that users and organizations have getting to containers and modernizing their workloads. We'll do an overview of GKE threat detection and take a look at how it works and how some of the pipes flow through the Google Cloud platform. Then we'll go into a demo on how a cluster might be vulnerable and how an attacker might compromise that cluster. And then, of course, how GKE security posture and security command center can help give you visibility to that risk and help you detect threats and react and respond. And then we'll wrap it up on how you get started with GKE threat detection and go to Q&A. So I mentioned that one of my passions is coaching youth sports, and the spring is a really fun time of year because we're kicking off all of the new seasons across basketball and baseball. And one of the things that I really like about Little League Baseball is that we have an opening day ceremony. So all of the different teams across the different age brackets get together, the community comes out, all the baseball families come out, and we get excited. We have a party to kick off the new season. And I guess I want to welcome everybody here at the session and next to opening day for GKE threat detection. We just launched or are launching here at Next. It's now available as part of GKE Enterprise. So you can log into the UI, activate it, and use it today. And I can't think of a better venue and community across Google Cloud, GKE, and Kubernetes users to kick it all off with. So thanks again for being here. And kind of like baseball, I think about cloud security as a team sport. Lots of different individuals come together with different skill levels and experience. And it takes a lot of teamwork, collaboration, and communication to really get together and gel and build a culture around cloud security. And you need to have that to tackle the challenges that are out there in today's security landscape. And so what are those challenges? Well, each year, organizations like the CNCF and industry analysts poll organizations and users about their plans to move to containers and what the #1 challenge is or the top challenges that they face getting there. And each year in those results, expertise comes up as a top theme. And even though we'll be celebrating the 10-year anniversary of Kubernetes this year, it's really challenging to recruit, hire, train, and retain a bench and team of talented Kubernetes and container engineers, especially those that have security expertise. And this shortage of expertise and the complexity of security and container technologies can really affect the confidence and pace that organizations have moving towards their container and app modernization goals. And almost half of the respondents cited that they had desires or plans to move or modernize to container-based workloads, but were yet to do so and yet to deploy in production. And perhaps some of that hesitation is warranted, because like in sports, if you don't have the right players or the right skills, or you haven't done the practice and the preparation, you're going to have a tough time when you go to competition and the stakes are high. And in cloud security these days, the stakes are higher than ever. And you really need to build a game plan, and a defensive game plan, as a matter of fact. And so what goes into a good defense? Well, it starts with understanding what the offense is going to do and being able to anticipate that and put preventative measures in place, and then being able to react and respond when they do make those plays. Craig, you're an experienced security engineer. You've been in the container and Kubernetes space for a couple years now. What are you seeing out there on the offensive side, and how are things evolving over the past couple years?
Sure. So we're seeing a lot of financially motivated attackers who are looking to do things like steal cloud computing resources to do, cryptocurrency mining, for example. And early on, the sort of initial way they were doing that was looking for things like leaked or exposed cloud platform level credentials. So, for example, a token that was mistakenly committed to a Git repository. And then they'd use that to then spin up a bunch of VMs and do their mining that way. But as folks have gotten a little bit more defensive in preventing and detecting those sorts of leaks, and that's gotten a little harder to do, attackers have also started to look at attacking Kubernetes directly. They've said, well, I don't need those credentials when someone's misconfigured a cluster, exposed it to the internet, and this orchestration service will gladly run and scale my cryptocurrency mining for me. So there's been that increased awareness and education among threat actors about Kubernetes, both how to use it for their advantage, how it's commonly misconfigured for them to exploit, and then they're using that education to create automated tools to do those sorts of attacks at scale. And anytime you have automated tools that can do these sorts of things, that drives down the barrier to entry for other attackers to get into the game.
So a combination of scarcity of expertise and experience and a growing frequency and sophistication of attacks can make container security quite a challenge for organizations. So let's take a quick look at a high-level view of how GKE can help. And it really starts with GKE as a mature and secure platform. Google has been involved with Kubernetes and the Kubernetes community since day one. So we have that decade worth of experience and maturity working with Kubernetes, hardening our platform, and a lot of that is baked in not only to the technology, but also the processes and the teams in how we operate and run it at a global scale. And we continue to invest heavily in our platform. For example, modern identity and access integrations and hardening initiatives to make sure that we're keeping pace with the ongoing trends in security and updates and best practices. We recognize the importance of compliance, and we've worked hard to achieve a high bar of FedRAMP High and sustain that bar over time for several years. And as vulnerabilities continually get discovered, we've got engineers standing by to implement the fixes. We're tapping into that feed and security intelligence of those vulnerabilities being discovered, and our engineers are making those fixes, making the patches available for our customers so they can get updated in a timely fashion without any disruption to their workloads. So on top of this solid foundation that is GKE, over the past few years, we've been investing more and more in an integrated suite of security and compliance tools through our GKE Enterprise offering to really help you, our users, and our customers secure and manage your workloads at scale. For example, as part of this suite of tools, we have runtime vulnerability scanning. And so when containers are deployed on GKE, we're able to scan and unpack those containers and look for vulnerabilities in the operating system or the language packs that you're using. And so you can get a really clear view of your vulnerability risk for your workloads that are running in production. We've got an integrated policy solution that can really help jumpstart your governance journey and your governance practice. And so that can help you move from kind of a reactive security posture to a more proactive security posture by putting in those guardrails and those enforcement points to make sure that the best practices and the secure configurations are there from day one and can't be misconfigured. And at Next, we're also, in addition to threat detection, excited to launch GKE Compliance that'll automatically assess your clusters and workloads against the CIS benchmark for GKE to give you an easy and fast way to get going on your compliance journey. And then to round out and complete this set of security and compliance tools, we're excited, of course, to launch GKE Threat Detection here at Next. So let's take a look at GKE Threat Detection. This is a high-level architecture diagram of our GKE threat detection offering. It's included with GKE Enterprise, and the first thing I'll say is that it's an event-based threat detection solution. And so sometimes you'll hear that referenced as ETD. And what that really means is that it's powered by logging. And one of the great things about Kubernetes is that all the different operations that you make on a cluster are logged. It has a very rich set of capabilities to do audit logging. And when you're using GKE, we've integrated those Kubernetes logs with our logging platform, which is, of course, cloud logging. One of the benefits of this log-based approach is that there's no additional installs or components that you have to put down on your cluster. So you don't have to worry about managing this component's lifecycle over time, or the things on your cluster interfering or competing for resources on your cluster. When you turn on threat detection at the project level, those logs that are flowing into cloud logging also start flowing to our ETD platform. And that's where those logs are all ingested at scale and made available for the individual threat detectors to do the analysis and fire the security signals if they find something. Each detector kind of has its own pattern of logs or threat profile that it detects. And in the event that it does find one, it's going to raise that security signal both to Security Command Center and to GKE security posture simultaneously. So all of this is happening in near real time. And so we're continuously flowing the logs and running the threat detectors and surfacing the threats. So in about a second or two from when an operation is made or the logs are generated on your cluster, those threat signals are going to start firing if the detectors hit and pick up on the attack patterns. I want to also note that we surface the threats in multiple places because we understand that security is a team sport, like I said earlier, and that there's two different teams or personas that are often involved in GKE security. And one of them is that central security and governance team who's generally responsible for a really broad view of risk assessment and risk management. And so that's maybe a SecOps team who's looking at threats, misconfiguration, vulnerabilities across the entire solution, so multiple products on Google Cloud, and across the entire organization, so across lots of different projects, and they really want to take that complete view. And then there's another persona that is really our primary user in GKE, which is the platform teams, right? And so often that expertise that's so scarce is isolated on those teams, and they're working out of their tool sets and processes that are closer to the platform or GKE. And so we've integrated these threat signals into GKE security posture so that those teams can use them in their native tool sets that they're used to and familiar using. For example, a platform team might want to be using the GKE Fleets feature and get a fleet-based view such as test, dev, and production view of threats. And they can do that through the security posture tool. So Craig, maybe you can tell us a little bit about the framework that we use to approach threats and a few examples of the threats that we support in the preview.
Yeah, absolutely. So what we're looking at here is based on the MITRE ATT&CK matrix. And MITRE ATT&CK is a really comprehensive framework, and it's the standard way for a lot of folks to talk about and categorize the tactics and techniques used by threat actors throughout the entire course of a security attack. GKE threat detection is launched with a set of detection rules categorized by MITRE ATT&CK that give visibility into nearly every tactic category provided by, defined by MITRE ATT&CK. So from an initial access to then getting into the cluster, moving things around, there's tripwires set up all along the way. This is all based on real-world behavior of attackers that we've seen targeting Kubernetes, and we're going to start to move into a live demo where we're going to show some examples of that. So before we jump into that, just set up the scenario. So for this scenario, we have three main personas. We have a Kubernetes operator who's responsible for managing and configuring GKE clusters in the org, deploying workloads on behalf of development teams. We have an attacker who's scanning the internet looking for misconfigured clusters. And then we have a security and governance lead who's responsible for the overall security posture of the entire organization, things like vulnerability management, configuration, and threat detection. So we'll switch over to the demo. All right, so I've got my operator hat on. And our organization's kind of early in our cloud journey. Whoop. What happened?
You take the demo to the screen.
There we go. OK, so our organization's kind of early in our cloud journey. We are just trying to figure this Kubernetes stuff out, and we haven't refactored our applications yet, and I am just tasked with getting things up and running, getting teams the access that they need. So I'm just going to give our dev team some access. They need admin access, but what I'm actually inadvertently doing is giving system anonymous cluster admin access, which opens up the entire world to have admin access to this cluster. So I'm going to create that binding. And I've also been asked to deploy an application on behalf of the e-commerce team. So they gave me some YAML here that I'm going to deploy. And I can see it's asking for some things that don't look great. It wants privileged access. It needs access to some host namespaces. But again, I know they haven't refactored their app yet. They're used to running on a VM where they had all this access. So we're just going to get it running for now, and we'll see how things go later. So switching hats, I'm going to switch over to the attacker's machine. Now, as an attacker, I have some automated tools where I can look for clusters that were misconfigured. And lucky for us, it doesn't take very long to find that one that was just set up. I'm going to quickly create a configuration file that lets me use kubectl, the standard kind of way to interact with the cluster. And I'm just using the anonymous access, which is essentially no authentication at all. So I can double check, make sure that everything works, and I can see some pods are running here. I could see this customer app that the operator set up. And so I know that the anonymous access is working, but there's several ways to authenticate to a Kubernetes cluster. Clearly, anonymous is a choice you can make, and probably not the best one. And as an attacker, I know that, and I know if I got in that way, so could somebody else. So I want to set up something a little more persistent. One of the nice ways, one of the ways that we can do that is through a client certificate. Kubernetes has what's called the Certificate Signing Request API, where it will issue and sign certificates that can then be used for authentication to a cluster. The nice thing about that for me as an attacker is they're long-lived, they can't be revoked, and they would need the cluster's entire certificate authority to be rotated to invalidate this. So I like that idea, and we have this big messy blob of base64 encoded data that's not very interesting or to look at, but we can sort of tease that apart to say, all right, this is just asking Kubernetes to create and sign a certificate for this new user who we've decided to call cluster admin as a way to blend in with the default role that exists in all clusters. So I send that CSR, and now the next thing that needs to happen is that the signing request needs to be approved. Now, this normally needs to be done by someone with a lot of privileges. Lucky for me, again, I already have those privileges thanks to that initial misconfiguration. So I can just approve this for myself. All right. Cool. So that's approved, and now I can grab that certificate to be able to authenticate to the cluster instead of using system anonymous. But first, I'm going to clean up my tracks. Now, these CSRs will automatically be deleted after a period of time, but what we've seen is attackers are actually just using this delete CSR command and cleaning it up themselves, which, all of these commands that are happening in the background are generating logs that then go into threat detection, and this is triggering a lot of stuff that we'll show in a few minutes where this anonymous user is doing a lot of things that you wouldn't expect an anonymous user to be doing. So we clean up our tracks, and now the next thing to do is give myself some permission. So I created an identity to authenticate to the server, to the cluster as, but it doesn't have any permissions yet. So once again, our friend cluster admin comes to the rescue, and I can create a binding for my new user to that role, which gives me those permissions. finally, I can check, make sure this client certificate now works. I issue an auth can I list command, which will give all the permissions I have for the Kubernetes API. And all those stars tell me I have all the permissions. I can do anything. Great. Last step, this is what I came here to do. I'm going to run some cryptocurrency mining on this cluster. I'm actually not going to do that. This is pretty benign. I think it would make my reports a little awkward. So we're just going to run this instead. We get this up and running, and we double check that everything's good. Cool, so we're in business. All right, so if we go back over the slides, we can do a quick recap. So what happened? Our operator applied a misconfiguration by creating that initial cluster role binding that opened things up to the internet. Our attacker was scanning the internet and found it, quickly established a more persistent method of access, elevated their permissions, and then cleaned up their tracks before they launched, their intended malicious payload. So Daniel, what was the security and governance team seeing while I was busy breaking in?
Yeah, so let's say that I'm part of that central security team I talked about, and my job while I'm on my shift, maybe I'm on a SecOps call rotation or something like that, is to make sure that any alerts or notifications that come through get handled, or at least investigated. And so I was sitting at my desk on a Tuesday doing some project-based work, and all of a sudden I got this mail. This is just one example of how you can get alerts and notifications, hooking into Security Command Center or even Google Cloud observability tools. We also support, SMS, and there's integrations with, third-party products like Slack or PagerDuty if you want to send it right to a call rotation. And so while I am on the security team and an expert in some things, actually, I'm not a Kubernetes expert. And most of that expertise is actually on our platform team. And so one of the things that I'm going to do if I get this type of alert is I'm going to engage my colleagues on that platform team and ask them, hey, are you seeing any of these signals? What's showing up in your tools? And ultimately, hey, could you help me take a look at this one to make sure this isn't something serious that we need to escalate and run an incident on? So Craig, you're on the operations team, right? Could you help me with this one?
Yeah, absolutely. So I've got my attacker hats off, and I'm back on the operations team here. And if we pull up the demo, cool. So this is, Daniel mentioned earlier, we have this suite of tools, this platform, to give visibility into security issues happening in your GKE clusters.
So Craig, before you go on into the details of some of the threat stuff, I wanted to just take a minute here. What we're looking at is GKE Security Posture. This is one of those integrated tools that we have as part of GKE to help you with your security. This is where that vulnerability scanning, we've got integrations with threat detection, we've got misconfiguration checks, and all of these different security signals, are scanned on GKE clusters and workloads and surfaced in GKE Security Posture. One of the things that our customers have been asking for a while, and we're excited to be launching here at Next alongside the compliance and threat tools, are that all of the signals that you see here in GKE Security Posture now also flow into Security Command Center. And so it's that better together story. It's that collaboration across the different teams and personas to make sure that there's a single source of truth on these security findings, but that they're available in the different tools and workflows depending on which persona needs to consume them, or different integrations such as sending them through SCC into a SEM tool. OK, Craig, take us down through the demo.
All right, thank you. So we'll zoom in here a little bit.
Oh, did I push that? Oh, back to the demo, please.
Demo, please, yeah. Thank you. All right, so we'll zoom in a little now that we can focus on some of these cards. The first one up here, though, I just call attention to. This is an existing feature of Security Posture where we have this workload configurations. And so if you recall, our operator was deploying that app for the e-commerce team, and we said there's probably some things that they can do better here. And this is getting called out for them with workload configuration. So we saw they were running with a privileged container. We saw that they were accessing some host namespaces. And so when we go into this, if we're a team is just trying to figure out like, well, what does that mean, host namespace, and why should I care about that? And we have some recommendations here to help teams along, so the operations team can work with the e-commerce team to say, hey, do you really need this? Can we find out a safer way to do this together? But let's move on to the threats, which is what we came here to talk about. And this is where we can see the near real-time activity of the attacker as they were accessing and exploiting the cluster. If we look at this first one here, the privilege escalation, this was created with the initial configuration by the operator who binded the cluster admin role to the system anonymous user. So we have a description of what that was, and then a recommended action for how to remediate that. We can also see which resources were affected. If we have multiple clusters in our fleet, we only have one for this demo. Now you'll notice we actually have two findings here. The first one was from me as the operator creating that initial binding, but then we had that system anonymous trigger as well when the attacker bound that new user they created to cluster admin. So we see both of those here. And from here, we can go a couple different ways. If you're an operator who's comfortable looking at Kubernetes logs, we can pop right over to the log query that'll bring you to that event. Or we can also go into SCC and see what the finding looks like over there. In SCC, we get things broken down a little bit more. We get a little bit more detail. Not only do we have the person who did this, which was me, we have their IP address, where this was coming from, what client they were using. That'll help call out like, oh, we usually use kubectl, but this was coming from curl. That doesn't seem right. And we also have the name of the binding, which you can then use to see, are there any other findings related to this binding that the user created? As well as what we saw earlier with like which cluster was affected, which zone, how widespread is this? From here, we can also, if we want to see the raw log, if you're comfortable with Kubernetes audit logs, those are available too. And it has exactly what you would expect. It looks very similar to the YAML that was submitted, where we had this cluster role binding called cluster system anonymous for the system anonymous user to cluster admin. Cool. So back in security posture, the other findings tell the rest of the story. We had some initial access where an anonymous attacker was creating resources. The resource they created was that certificate signing request. Then they modified some resources. The resources they were modifying were they were approving that CSR. They were deleting that CSR. These things are picked up when the logs are processed by event threat detection and surfaced as threats for us to continue to investigate. And finally, we had the privilege escalation when they launched a privilege container with that fake cryptocurrency mining. So if we go back to the slides, we were alerted to what the attacker was doing nearly every step of the way. From the misconfiguration as soon as the cluster was exposed, to the attacker moving through the tactics we discussed for MITRE attack, from initial access and privilege escalation and beyond. And this gave us real visibility and decisions along the way to say, okay, what exactly was happening as they were exploiting this cluster? Well, if we take a step back, and now we can talk about our threat response lifecycle. And both how teams can use threat detection to respond to security events like this, but also how Google Cloud tracks trends and tries to improve security for all clusters. So it started out with our threat team getting an alert and spinning up the incident response. Daniel pulled in the experts on the Kubernetes operations team to investigate further in security posture. And as the operations team, we'd prioritize that highest severity alert first with that misconfiguration and remove that. Then we'd continue to triage and address the other alerts that came in to see what else was the attacker doing and what else do we need to clean up here? What else do we need to do? But as threats change and Kubernetes evolves, we want to make things like this harder from the start, right? That initial misconfiguration that sort of started all of this. And while we're starting off with an alert to say, hey, this misconfiguration happened, you don't want to do this, we're moving to do things like we're blocking that binding from happening entirely, starting in GKE version 128 and later. These are the sorts of things that our team on GKE security are always working on. That about wraps up our demo. Daniel, you want to talk about how folks can get started using this?
Great. Thanks, Craig. Really cool demo, and it it's fun to kind of see the whole life cycle there for when a cluster could be vulnerable due to a misconfiguration, and we provide you visibility into that so you can be proactive before you get attacked, as well as then that whole sequence of events and getting visibility for a response. So yeah, getting started is super easy. It's a 1, 2, 3 type process. So the first step to getting started with GKE threat detection is to get started with GKE Enterprise. And if you haven't started with GKE Enterprise yet, there's a great 90-day free trial that you can try it out, and you can activate it on a per project basis. So that'll get you going and get you kind of access to that suite of integrated security tools that I talked about earlier, including threat detection. Once you've got access to that, you enable threat detection at a project level. And so that'll get those logs that are going from the Kubernetes logs into cloud logging, flowing into that ETD platform that we saw in the architecture diagram so that the gears can start moving on generating the threats and doing that threat analysis. And then lastly, in GKE Security Posture, part of our feature enablement model is per cluster configurability and flexibility. And so we'd recommend that you select all clusters, enable threat detection to make sure that you have that visibility in security posture. But if you do want to start with one cluster there or have certain requirements where you maybe want to turn some off, that is an option to you. One nice thing about this setup flow is that it's all powered by really simple click-through UI. So you don't have to bust out your G-Cloud or your API to set any of threat detection up. And going back to that kind of architecture diagram, you don't have to install anything on your cluster because it's all log-based. So maybe 10 minutes to go through some of these workflows if you're reading the text and the details and not just clicking through. And then once you've set it up, it takes about 15 minutes or so of initialization to actually get those logs ingested and start that mode of continuous monitoring and surfacing of threat signals across both tools. So super easy to get started, and hopefully you'll take that as one of the actions out of the session. Wanted to take a minute to just recognize that we're celebrating the 10-year anniversary of Kubernetes out here at Next and this year. And so actually over 314,000 contributions to the Kubernetes project across 74,000 unique contributors. So a really special project and something that we're really proud to have been part of and a major contributor of. And so just wanted to take the opportunity to thank everybody who's involved in that community and has contributed to Kubernetes for being part of that milestone. And on behalf of the GKE team, we're looking forward to the next decade and kind of building the future of Kubernetes and containers with that group. Couple sessions that I'll mention that are worth checking out. There's a kind of past, present, future overview session of GKE that I would recommend. And if you're interested more in some of the tools in Security Command Center and how you might mobilize and run a response to an incident, so if you see those threats piling in and you're having that kind of oh no moment and you need to kind of have that process practiced and prepared for when you need to actually run an incident, there's a good session by our colleagues on the SCC side that are covering some of that incident response tools and techniques. And then there's a session on the GKE compliance. Unfortunately, it's happening now, so you might have to check for the recording on that one. So just wrapping up here, we actually have a lot of GKE product managers and UX researchers out at Next. They would absolutely love to meet with you, especially our UX research team. There is swag involved, and so if you're interested and have a half hour that you'd like to sit down and see some of the future direction of where we're going with GKE and weigh in, please scan the QR code, and there's a short little form that you can fill out, and they'll get in touch with you while you're here. And so, yeah, we've got a few minutes for Q&A now, so I want to thank everybody again for coming into opening day of GKE Threat Detection, and we'll take some Q&A. I'll leave this up. All right, I think we have some people with mics. We'll go ahead and pass them around.
Yeah, so just how does this translate to Anthos?
So GKE Enterprise is like the evolution of Anthos, right? And so some of the products and technologies that were in Anthos are available as part of GKE Enterprise, and that kind of Anthos brand name and offering name is really moving to GKE Enterprise going forward.
Hi, this is Raj here. Quick question on the GKE security posture. There are security CVEs which you detect naturally, and there are some third-party tools we have in our platform which we monitor. How do we engage with GKE team to prioritize and patch it? Because that is one of the challenges we see in our platform.
Okay. And are you talking about?
From a Google standpoint, they are not agreeing it's a CVE. It's not secure, like it's not a priority from their side as a patch. So how do we engage with you guys to prioritize that patch? What is the process involved in it? That's all my question was.
So, I mean, generally those requests come in through technical support. If you want to sync up after, I can provide you my information as another channel. But there's a couple factors that go into kind of the CVE patching process, right? So anytime we get a CVE on components that we run or use as part of our managed platform, it goes through our internal process to do assessments on whether or not that CVE, we are actually vulnerable to it. And so there's times where there's a CVE in a language pack or others, and that it gets evaluated where the risk isn't present due to how they're using the technology or other factors. But in general, we're swatting and patching those CVEs pretty regularly. So it's a case-by-case basis there. Is there anything else you want to add to kind of that process? I think the other thing that I've heard is that sometimes teams point scanning tools at the control plane. There's sometimes CVEs that there's no fix available to, which currently we don't surface in GKE security posture, but is something we're looking at going forward. So I guess it's a case-by-case basis. I would go through technical support if it's really something that or your CE or TAM, if it's really something that you want to sit down and have a conversation around and understand our justification for. But if there is a threat of a CVE, we're definitely working on the patch and rolling it out.
Thank you.
Mm-hmm.
Yeah, I have two quick questions if possible. So the first one is, so I'm focused more on like threat detection and response side, and SCC had a set of Kubernetes audit log findings already. So I guess like with this, is this mostly like an expansion and a bunch of new rules being added to that, or how does that like compare to the existing SCC offerings there?
So we've partnered with the SCC team on this, and we are leveraging the investment that they've made in existing ETD and Kubernetes threat. There's two flavors of threat detection for Kubernetes in SCC: ETD, the log base, and KTD, which does run the agent or a component on the cluster. And so part of this is a packaging of the SCC capabilities that they have through ETD available through GKE Enterprise offering, so you don't necessarily need to buy SCC Premium to get those capabilities. It comes with GKE Enterprise. And as well as that, part of that partnership is we've been investing in new rules. So I think we added a few new rules here for the launch, and then we've got a roadmap of more rules to add. And so we're helping out, piling in, and joining forces with them to basically have one source of truth and one investment stream on all Kubernetes threats.
Awesome, yeah, thank you. And the second one is org enablement on the roadmap? Like, because you said at this point you have to do it at the project level per cluster. So I'm wondering, we have a lot of projects, and I'm wondering if org enablement is scoped.
Well, it's definitely something I'll take back to the team now that we're getting the feedback. If you're an SCC Premium customer, you can turn on ETD at the org-wide. They do a lot of org-wide enablement, and oddly enough, they're offering now project-level enablement because a lot of customers need both. But there's other tools like org policy and other things that might help you kind of get into that posture of turning on all your clusters with threat detection and the projects. Long story short, today you have to flip it on per project. It's a pretty easy one click, but I understand that it has to roll out across many projects. Yeah.
Thank you.
Yeah, I've got a question. So Since this is based on cloud logging, is there any plans to open this up to other Kubernetes distributions that are taking advantage of cloud logging, or right here, sorry, taking advantage of cloud logging and running on-prem or in somewhere else in Google Cloud?
So I'll let Craig answer on any distributions there. I will say, though, that part of our security posture tool set that we have right now, it does support GKE on GCP clusters, and we are looking at expanding that roadmap of those tools to like more of a multi-cloud posture. So that would include like attached clusters, even EKS or AKS clusters, because with the GKE Enterprise offering, we really want to be able to kind of wrap our management tools around all your different Kubernetes clusters. As far as like different distributions of Kubernetes.
Yeah, so it's not. I don't think that's something for the GKE tooling here. But there are other like cloud security products though within Google Cloud, like Chronicle, that might be. They're more like distribution agnostic threat detection rules as well. That might be something to look at.
Yeah, so we'll probably start with the clusters within the scope of our multi-cloud strategy, and then I guess no plans right now for non-GKE or GKE Enterprise scope clusters to flow into threat detection. But good feedback.
Hey, great talk. Just a quick question on those threat detection rules and stuff. In regards to like syscalls or like anything weird that's going on at that level, is that something that you guys are able to capture right now, or are the rules something that we can write as well to capture those types of things?
Yeah, great question. So the syscall stuff will come in as part of like the runtime detection. So Daniel mentioned like that KTD part of SCC. So that's not part of what's included in GKE Enterprise right now. But that is an option in like SCC Premium to have that sort of thing today. And I'm sorry, the second part of your question was?
Oh, just regarding like the threat.
Oh, writing your own rules. Writing your own rules. So right now, no. These are, we're trying to make rules that are a little bit more focused on like operators. So they're not necessarily writing their own rules. This is just like, hey, here are some built-in rules that we can provide for you. But that's good feedback as well, just for like customization or writing rules in the future. So thank you.
I have a non-enterprise cluster. Can I just turn on enterprise without redeploying? Can I turn it off if I decide it's too expensive? And can I do that all with Terraform?
Yes. So yes, so you can enable the GKE Enterprise API at a project level, and then in the current billing paradigm, you create a fleet, and you can put your one cluster in the fleet if you want to try it out, and then you'll be billed for that one cluster only. And then you can turn off the API to opt out of it at the project level, or you could actually even just move that cluster back out of the fleet, and the features would no longer be, you wouldn't be entitled to GKE Enterprise anymore. So yeah, you can do that.
Hi, first of all, thanks for the session. I got one question regarding the global or log detectors. As it's based on cloud logging, can I make sure the detectors are in a region I want them to be, or are they central or in global region always?
So just to clarify the ask, it's that you want everything to happen within one region, yes, and not have multiple different regions piling logs into a central place. Is that the goal?
In a set of regions that are applicable to my workload and the company regulations I'm in.
Right.
So it's hard to use services that are in global sometimes.
Right. So that is actually something that we've been discussing, and on the SCC side, it's a data residency feature that Security Command Center is working on. And so today, by default, if you were to go out and set up threat detection in that 1, 2, 3 sequence, SCC would be instantiated and enabled, and that ETD platform piece would be running as a global kind of data residency, where the GKE is regional, and so the different GKE clusters across different regions would pile all their logs into that one, globally replicated store of logs. SCC is working on their data residency model, where they can then have a single region to support. I'm not sure if they've actually launched that or not. So that's something that I could get your info and follow up on. But we do have kind of plans and disclaimers actually in our experience that say, hey, that's going to happen. And we've got roadmap with the SCC team to support regional-based instances of Security Command Center exactly for that need where they don't want logs crossing those boundaries. So it's on the roadmap, and it may be out in early preview on the SCC side right now, but I have to confirm that.
All right. We're at time,
Okay.
but we'll be around.
We'll hang out, and then definitely come by the booth. We'll be there, too. So we'll hang out. We got to get off the stage for the next group. Thanks, everybody.